This is Natalie Mendez explaining my code for Chapter 4, Problem 5. In this question, it asks us to construct a function for a spiral, as you can see here. And the only difference to the second spiral that it's asking us to construct is a difference by a turn angle. So the first thing I did was I imported the turtle and I assigned the turtle to Tess. In this example, it asks us to make it light green with the background light green with the Tess color being blue. So that's what I did here with this BG color with light green in parentheses and Tess color being blue. This pen size looks pretty thin, so that's why I assigned the pen size to be 0. And in order for both of these spirals to fit on the page, I picked up Tess and I moved her to the left of the screen 200 units. So that's why you see this Tess backwards 200 units. And then I went ahead and I put the pen down so that Tess can actually start making these spirals. So this first function that I made has 5 variables inside of it. So there's t, angle, start, delta, and n. I first assigned size to start because it's going to actually be inputted into this delta function later on. And that's because we wanted to orient itself in a certain spot, and then we want it to move to this spacing of delta. It's like a buffer almost that moves it over delta units. So in order for that whole thing to happen, I made a for loop, and I made the for loop for a function of n, or for the variable of n, and this size plus equals delta is going to make that buffer, like I said earlier, either smaller or bigger depending on what values I put in there. But these look to be pretty tiny, so that's why you'll see later on why I made it to be a small value. And Tess is going to go forward a size of whichever value I decide to put in there. Again, these look pretty small, so that's why this value is going to be relatively smaller down here. And then Tess is also going to be making angles of right angles. So that's going to be an angle of 90 degrees. That's how we get this this nice square looking spiral look that we're going for here. So then I ask Tess, I put this function down here and I started inputting the values for Tess. Like I said, we want to have this 90-degree angle to make kind of the square, but also we want to have a really tight buffer so it kind of brings out these concentric lines out a little bit, but not by much, but just enough to make that difference. So I assigned the turtle to Tess. We're making 90-degree angles. We're starting at 1, and then we're buffering out a value of 2 units to make just those tight spirals. And we're going to go ahead and do that 100 times because this looks like this is a pretty significant amount of spirals that this question is asking. I don't know if it's actually 100, but I'm guessing that that's about the value that they're looking for. And you'll see when I execute the function that it looks pretty similar. So that explains the first spiral that we made here. Then I went ahead and I picked up Tess. We moved her to the right 400 units, and then I had to manipulate the function a little bit to make it so that she can orient herself back to the east-facing side of the screen. So that's what this code is doing here. It's just basically picking her up, moving her across the screen, and putting her back into the direction that she was facing earlier, which is this direction right here. And then what I did was I made another spiral function because the only difference between this function, this first spiral and this spiral, is a matter of shifting it a certain amount of degrees. So what I did was I just did another spiral right beside the first one, and I made it a negative 91 degrees. And you'll see when I execute that it's very, very similar to what it's actually asking for. So there's the first spiral, and there's the second spiral. And yeah, there we go. So like I said again, this is just basically 90 degrees kind of going in concentric little spirals. And then this one is it just that even the 1 degree difference can really alter the way this spiral looks. So yeah, this is Natalie Mendez again, explaining her code for problem 5. And thank you so much.